Hey everyone. Apparently there was some problems with the previous video with some screen sharing, so hopefully this one works for us. I'm going to share a screen. I'm just going to start with this. I'm going to share a screen with respect to the StatCrunch program. So let me share that. There we go. And so this is a blank StatCrunch sheet. I'm going to build a contingency table on it. Now remember, a contingency table is two variables and it has the frequencies. It has rows and it has columns. So how I build a contingency table and do a chi-square test is I go to tables and I select contingency and I select with summary in this case. Okay. And now I'm going to put this as the rows, and then I'm going to have the columns be variable 1, 2, 3, and so on. So I'll show you what this is going to look like. So I'm just going to duplicate a contingency table. So what we had with the contingency table that we're going to do is we had the sex or gender of people, and that was female and male. And then going across, we had times of day that the fatal accident occurred. So we had, something like, I don't exactly remember what it was, but it seems like it was something like 12 a.m. to 5:59 a.m. Then we had (6 a.m. to 11:59 a.m. Then we had 12 p.m. to 5:59 p.m. So afternoon, in other words. And then last but not least, we had, we had what, 6 p.m. to 11:59 p.m. And then we had the data. So I'm just going to make up some data here. So suppose we had 345. Then we had for males at 12 to 5:59. Let's suppose we had 231. Then we had for females 6 to 11:59. Let's suppose we had 567 and 398. And then we had from noon until 6, 805 and 608. And then from 6 to 11:59 p.m., let's suppose we had 911 and 712. Okay, just making up numbers. So I basically have the contingency table duplicated there. So now what I'm going to do is I'm going to select contingency table, just like we talked about, with summary. And now I've got to tell, this first thing says, well, what are the row variables? Well, the row variables were sex. They were male, female. So I highlight. I select and highlight that, I should say. Okay. Then what are the column variables? Well, the column variables were the times. Okay. So I'm going to actually put those in. How am I going to put them in? I'm going to point and I'm going to click. So to do that, I press Option and Shift. And I click. I want to unclick that one. Let's get rid of that. So I'm going to click this one. And then I'm going to Option, Shift, click the others. And then I'm going to compute. And it gives me the information. It tells me my test statistic is 3.369. And it tells me my p-value is 0.3381. So from that, those are my steps 3 and 4. I can determine whether or not I should fail to reject or reject. And then from that, I should be able to determine whether or not I support or don't support the claim. So basically, what we have here is we have the process on how we make a contingency table. Okay? And you're going to have to do that for that problem in the handout that you saw. Okay, the next thing I want to talk about is I want to talk about the ANOVA test. Okay, so I'm going to add some data here. I'm going to put a column here. And let's call this, I think we had Southeast Michigan. I'm not going to duplicate this exactly. West Michigan. Might have been Southwest, it doesn't matter. Mid-Michigan, and Northern Michigan. Then we had, I think, the UP. However, let's just put some numbers in. So let's suppose we have 23,000, 31,400, 28,900, and let's suppose we had, how about 17,900. Okay, and then for West Michigan, let's suppose we had 34,500. We had 31,230. We had 29,890. We had 29,000. And then we had one more. Let's suppose we had one more location. Let's suppose we had, 31,750. Then for Mid-Michigan, let's suppose we had 23,000, 27,800, 23,090, and 31,000. Then for Northern Michigan, let's suppose we had 34,500, 21,000. Oops, that's way too much. 21,000, that's better. Let's suppose we had 17,890. And we had, how about 21,000 again. Okay, so now I have the 4. You're going to have a 5th column for Upper Michigan, which would be the UP. However, so we have 4 groups. We have 4 populations. So mu1 equals mu2 equals mu3 equals mu4. You would have 5. The alternative would say at least one of the means is different from the others. Doesn't tell us which one. Now we go over to stat. We go down to ANOVA and we select one way. And now I'm going to select the columns that I put that data in. I didn't put the data into the time columns. I'm not interested in those. So I'm going to select Southeast Michigan, holding down Option and Shift. I'm going to select Western, Mid, and Northern. And then I'm going to hit Compute. And it gives me this information. Now all of this is important. This tells us the sample mean and sample standard deviation for each of the samples. This part, though, is really the meat and potatoes of it all. This is the test statistic, 1.94, and this is the p-value. Okay, and so that's how we do an ANOVA test to get steps 3 and 4. Then from there, we can conclude. Hopefully this helps you out and explains some of the things that you were having that really didn't come through when we did the Zoom recording last time. So I'll upload this and record